Hello, everybody. Welcome back today. And today we're going to be talking about LeetCode number 945, which is minimum increments to make the array unique. And that's actually the problem of the day. So let's get into it. All right, so I'm going to explain this on my iPad here. And so our input is a vector, and this vector has integers in it, and it has repeating integers. So the whole point is that at any time, you can go to any index in this vector and increment that number by 1. And so what we want to do is we want to find the minimum number of times that we want to increase some of these numbers so that all the numbers in this vector are unique. So in this case, we have 1, 2, and 1, 2, and 2. We would want to have 1, 2, and 3, right? Because that will make our vector unique, all the numbers in the vector unique. So we would increment this 2 by 1, and that's why our answer is 1 here, right? Similarly, on this second example here, we have 2's and the 1's repeating. So we would want something like 1, 2, 3, 4, and then 5, 7, right? And this would make our answer unique. And apparently it takes us 6 increments to get that. So let's find out how that's actually happening. So if I were to rewrite this here, and think about like how I would do this, right? So first things first, right? It wants the minimum increment. So first thing is like if you want the minimum, it's like an extreme. So maybe there's some kind of greedy approach, right? It doesn't want just any, it doesn't want just any amount of increments. It just wants the minimum number in increments. So we want to see if there's any kind of greedy approach. And the one thing I can think of is like it's kind of hard to just look at this and say what the number should be. But if you saw how I wrote it out previously, I kind of wrote it in a sorted order. So maybe we should sort this vector first, right? Let's just say we sort the vector or array depending on the language. Sort the vector. So if I did do that for this example, so I'd get something like this, right? Now, if I think about it, then maybe we can just look at which ones are repeating and increment those. So what I mean by that is, let's start here, right? We know this one is repeating. When we look back, is it repeating? It is, right? So maybe we increment this, right? Then we have this as our array. And then we see this 2, yeah, the 2 is also repeating. 1, 2, then we increment that, right? So we have a +1 here, +1 here, right? And then we see this 2 is also repeating, but this is from like before, right? Not the previous index, but like index before that. So we increment that, but we don't increment it to 3, we increment it to 4, right? Because then the 3 would also be repeating. So we increment it to 4. So that was an actually increment of 2 because we incremented it +1 twice. Same thing here, we have a 3, and then we're like, okay, this is also repeating, right? And so we increment that, but we have to increment it to 5, right? Because we don't increment it to 4 because then it's also repeating. So we increment it again, and this would be also an increment of +2. So that's why here we add these up. Oops. We add these up and we get 6, right? We have 4 times or 6 times we have to increment by 1. So that's kind of what the question is getting at. Now, how do we go about doing this, right? So again, we said we sorted this, so we kind of greedily chose that we're going to deal with the smallest numbers first kind of thing, right? But why? Why are we doing that? Well, the point is, if you think about it, when we were incrementing by 1, right, and we were incrementing by 2, we were looking at the max number, right? But when we sort it, we know the one that's before, like the last element before, right, is going to be the max number, right? So the relationship that I'm going to write out here, I'm going to explain it, is something like this. This is what we're going to look for, okay? And how does this make any sense? So let's think about it, right? We have this, right? And we're going to start at the first index, right? We're going to check, is my array at this current index less than or equal to the previous index? It is, right? It's equal to 1. So what we do is we increment. So we're going to increment, and I'm going to have a counter, right? So my count is now at 1. That's how many times I've incremented, right? And this is going to be our array. Then we're going to be here. Is this also true? Yeah, we're going to increment again, right? So 1, 2, 3, 2, 3, 7. Then we move here, and then yeah, this is actually now less than. That's why we have the less than. We don't just have equal because we're going to be increasing these elements, and we're not sorting every time we increase, right? So we're going to make sure that if it's never actually in sorted order, we want to increment it up. So this time, what should this number be? It should be 4. It should be the max number, which is the one before plus 1, right? That's what it actually should be. And so to do that, we're going to take this previous number plus 1, and then we're going to subtract it by the current number, and that's how many times that we have to increment. So that's going to be a +2. So this becomes 4, right, as our count. Then we go here, 1, 2, 3, and now this becomes a 4. This is a 3 and a 7. Again, this is less than, right? This index is less, the element is less than the one before it. And then again, this should be a 5, so it's going to be a +2 again. So it's going to be a 6. This becomes a 1, 2, 3, 4, 5, 7, and this is good, right? Because this is actually greater. So now we get our final answer is 6. So let's check this out in code, and let's see how it's done. All right, so let's get into the code here. So this is the question that we talked about. And then the first thing we want to do is we want to sort, right? So like we said, this is going to be our greedy approach. So by sorting, it allows us to have that relationship between the current element and the previous element because we know that since we sorted it, the previous element has to be the max, right? When we're changing it. And then we're going to have a count variable, which is going to keep track of our count. It's actually what we're going to return. So I'm just going to put the return statement in. And then we're going to iterate through this array or vector, and I'm going to start at the first index position. So that's the second element because we can compare with the one before it and go through the entire vector here. And remember, we want to keep track of this relationship. So we talked about I minus 1 and I. So we want to check if nums at I is less than or equal to the one before it. So I minus 1. If that is the case, then we want to increment this current element, right? So how we're going to increment is we're going to change this count. And the count, we want to change it to the previous element plus 1, right? So it's going to be I minus 1 plus 1 minus the current element. And that's going to be the difference. So that's how many times we need to increment. And then we're going to change the current element to that previous elements plus 1, right? And that should be it. If you think about it, that's the entire algorithm right there. So if we run this and just make sure that we pass these test cases, and yep, we passed that and we submit it, and this should pass all the test cases that LeetCode has set. And if you want to talk about the time complexity here, this is going to be at least n log n, right? Because sorting always takes n log n. And we have this other for loop that goes through the entire array, which is plus n, but that's a smaller order of magnitude than the n log n. So our sorting algorithm is going to take majority of the time complexity here with n log n. And then space complexity is O of 1 because we're not using any excess space, like a hash set or anything like that. And there are solutions that where you could do that, but it doesn't really make any sense because we're doing the greedy approach. So this should be the best time complexity. But yeah, let me know down in the comment section below if you think that I missed anything or if you have any confusions about the solution or the explanation. And make sure to like this video, subscribe to the channel. I hope to see you on the next one.